Hello, hello. So I didn't get a lecture to you guys out last week because I just really didn't have anything else to add to that one, and I don't figure you guys need me reading the lecture just verbatim off the slides. This will probably be true for some of these these last lectures coming up, just because a lot of it is just reading the material. There's really nothing else that I can add to it. But I will try and let you guys know sooner whenever I'm not going to upload. Now, today we're going to talk about the evolution of locomotion, more specifically about bipedalism, because that's what's relative to our human ancestors and our own evolution. So some key terms: locomotion, which is just the movement or the ability to move from one place to another. Bipedalism, which we've talked about before, is walking with two legs. Now, there are two types of bipedalism. So there's obligate bipedalism, and this is when it's regular. You are habitually walking on two legs, and very few mammals actually demonstrate this. Really, the only ones are humans and kangaroos. There's also facultative bipedalism, and this is an animal that's capable of walking or running on two legs in exceptional circumstances. So normally they're going to be walking or running on four limbs or more. Some examples of this are lizards and other primates. There's a couple others. Now, we do have other primates, especially within the great apes, that walk bipedally more often, so chimps and bonobos especially. But it's normally just to carry things for short distances. They're more often going to be knuckle walking rather than walking bipedally. Bonobos walk bipedally a little bit more often than chimps, but it's still not what you would consider regular like humans do. So we talked before about the Miocene and this kind of Planet of the Apes period. Well, by the late Miocene, a lot of these ape species go extinct, so there's no more Planet of the Apes. This is partially due to competitive exclusion, and competitive exclusion states that if all other ecological factors are constant, then two species competing for the same resources cannot coexist. Now, obviously, within any ecosystem, there are multiple animals and multiple species that are using the same resources, that are eating a lot of the same diets, and they survive just fine. However, whenever you have two species that are competing for the exact same resources, a lot of times an ecosystem cannot support it. And this was very true in the late Miocene because the environment was also changing, and a lot of these species could not adapt to these changes, so they died out. However, the late Miocene is cool because it's also when we see the first evidence of bipedalism in the family Hominidae. And we see this in Australopithecus. There is debate about some previous or some earlier ancestors also being bipedal, but the reason that it's pretty agreed upon that Australopithecus is the first ancestor we consider bipedal is because fossil records from before then, they just don't survive that well, so we don't have that many of them. A lot of them, we only have one or a handful of bones for the entire kind of species, and it's not really enough to say definitively that something was walking bipedally. It's also because we see kind of a mix of characteristics of bipedal and non-bipedal characteristics in these earlier ancestors. So it's hard to say whether they were obligate or facultative bipedal animals. And so we don't really want to make that solid of an argument. It's just easier and more agreed upon to say that Australopithecus is the first completely bipedal human ancestor. Now, Australopithecus, you guys are going to watch these videos. They should take you straight to them if you are looking at the lecture. And the first one is about Lucy. Now Lucy is the skeleton that you guys see here, and she is the typecast for Australopithecus. A typecast is essentially remains or kind of the essential. Sorry, my dog is whining in the background. A typecast is what you use to compare the new findings or other remains to try and determine if it actually belongs to a certain species. So it's kind of like the ideal specimen of the species. And biological anthropology is not the only branch that has typecast. Archaeology has a lot of it too, especially when you're looking at like stone tools or arrowheads or ceramic vessels. But Lucy's really interesting. Definitely go watch that video. Also within Australopithecus, we see something called the Laetoli footprints. And these were found by Mary Leakey. If you guys have not heard of her, the Leakey family as a whole actually is very famous within anthropology. They made a lot of discoveries and a lot of contributions to the field. But Mary Leakey specifically found these, and the footprints essentially developed as a volcano erupted. And after the ash all fell down, it happened to rain. So it turned all of that ash on the ground into kind of this muddy slurry. And when it started to dry just a little bit and animals started venturing out, they walked across it, leaving footprints. Well, because it was this kind of ash mixture and then it got hot and completely dried it out and everything else, it turned to stone. The Laetoli footprints in particular are these sets of footprints you can see in this photo here. And one of them is very obviously from an adult, and the one next to it is from a child. So there are different interpretations of this, but it's generally agreed that it was likely a mother with her child. There is also evidence that another person came behind them afterwards and kind of walked in the mother's footprints. And there's a lot of different interpretations of this. Some people think that it might have been her partner or another person of their kind of group that was like following and taking up the back to kind of watch out for predators, kind of protect them. Other people think that they might have been stalking the child and the mother, but we can't really know for sure. Now, with bipedalism, we see changes in the pelvis anatomy. I'm not going to read through all of these. You guys can do that on your own and look at the chart and cross-reference and all that. But we see it a lot in the sciatic notch, the sacroiliac joint, the acetabulum, the pubic symphysis, and the iliac blade. With bipedalism, we also see changes in craniomorphology. So our our facultative bipedal ancestors and other primates typically have a sagittal crest. So where we have our sagittal suture kind of up here across the top, a lot of these early ancestors and primates have a sagittal crest. And this is actually just a ridge of bone that goes across. It's pretty noticeable. There's really no mistaking it. But it is actually where there's a muscle attachment to the jaw. So anytime you see a sagittal crest, you can pretty well assume that whatever species it was had really strong jaw muscles. Now, modern humans, we don't have a sagittal crest because we don't need one. As we kind of learned about fire and we started cooking things, our diet started to become very soft and processed. So we didn't need super strong jaw muscles to bite through and to eat. Likewise, we also start to see post-orbital constriction. So this is narrowing of the cranium just behind the eye orbits, and it's found in most non-human primates and early hominins. This is just a general kind of development. As we get more bipedal, our faces and our heads, especially our prefrontal cortexes, get larger. We also have less prognathism, which is how far your jaw extends from the rest of your skull. You can see in this photo that by the time we get to Homo sapiens, it is pretty in line. It's pretty straight. And the reason for this is we don't need super strong jaw muscles. We're eating softer diets, and our jaws are getting smaller and less pronounced. This is actually also why we tend to have a lot of tooth issues, because we're eating softer, sugary diets. We're not working those muscles or using our teeth the way that they were initially meant for. That's actually where we see modern evolution kind of coming into play as well. So a lot more people are being born without wisdom teeth. And this is because we just don't really need them. The fact that we eat really soft diets, we're not grinding our back molars down as much, so we don't need that third molar coming in to kind of replace the ones we've already worn down. As we have been eating softer diets, our jaws and our mouths have gotten a lot smaller and a lot more crowded. So a lot of people, most people, when their wisdom teeth come in, they actually have to get them removed because they cause more issues than they do benefits. Now we also see with the skull some changes in the foramen magnum placement, and that's this circle in this top image there underneath the skull, and it's where your spinal cord connects. Now there you can see that the dog foramen magnum is pretty far behind because they are walking on 4 legs all the time. They're never really standing up straight. Yes, they can kind of jump up and get on your shoulders and stuff like that, but they're not doing that as their regular mode of locomotion. Now with chimps, we see it placed a little closer to the middle because they knuckle walk. So the angle that their head needs to be is more in line with that kind of back part of their skull if they want to still be able to move their heads and see. As things become more bipedal, we see the foramen magnum shift to the center or close to the center of the bottom of the skull. This is because whenever you are bipedal, you have to be able to stand up straight. To be able to do that and still support the weight of your head, the foramen magnum and the spinal cord need to connect more vertically and in the center. It also helps with weight distribution of the head and just general range of motion, especially since we do have forward-facing eyes. If we did not have this motion, it would be very detrimental because we would never be able to see anything on the sides or behind us. Along with that, we see the spinal column start to have more of a curvature. So you can see that humans have kind of that S curve versus the chimpanzees, which have a fairly straight kind of diagonal line. And this S curve in the spinal column helps with weight distribution, but it also helps so that our backs don't hurt all of the time from the weight of walking upright. The pelvis also changes, so we start to see wider but shorter hips. The chimpanzee pelvis, it is fairly flat and vertical. Whereas humans and even Australopithecus there, you can see it starts to take on more of a bowl shape with shorter but wider hips. Our knees also change, so they start to angle in from the hips to help with that weight distribution and the range of movement required to be able to walk upright. And then our feet also change. So when something is an obligate bipedalist, it has fairly unique foot designs. So we see that big toes are bigger, sturdier, and also more in line with the foot. We also see that we develop kind of this arch as a result of this design in the foot. And that's really important because without that arch, we would have nothing to absorb the shock from walking. And we would have a lot more issues with our feet. It would hurt a lot more. But it also, this unique foot design helps with balance and weight distribution, as well as just being able to run and things like that. Now, obviously, bipedalism is pretty great. It allows us to do a lot of things that other animals cannot. And some of these benefits include making it easier to pick up food and resources and freeing up your hands for carrying things. A very common interpretation of why we started to become more bipedal was that it made it easier to carry babies while also doing other activities. So it made us more efficient. Bipedalism also helps improve our fine motor skills. So because our hands are freed up, we start using them to do more intricate things, like the creation and usage of tools. A lot of people also believe that some of it was an intimidation factor. So humans are not very strong predators in the grand scheme of things, especially early human ancestors, which were dealing with megafauna, so woolly mammoths and, a lot bigger predators and prey that would have had a much more detrimental effect. They didn't have as solid houses and tools and everything that we do. So being able to stand up straight and appear taller and larger makes you more intimidating, and it would have saved you a lot of headache and pain whenever you came up against other predators and other large prey. It also helped humans cover wide open landscapes more quickly and efficiently. So walking bipedally, we have longer strides than most other animals, and so it helps with movement, it helps with migration. This is also why we start to see some early migrations out of Africa happening around the time that bipedalism occurs. But it also allows us to be built more for endurance. So if you didn't know, humans are actually one of the best, if not the best, endurance animals. This results in a lot of long distance hunting strategies. So early humans, especially before they had complex tools and weapons, they would basically just tire out whatever their prey was. So instead of traditionally hunting like we think of, they would track and follow their prey until it could not go any further. It would collapse from exhaustion, and then it was just kind of a done deal. Now, unfortunately, being bipedal also causes some unfortunate results. So, most people have some back pain. We see a lot of scoliosis. There's a lot of slip disc, arthritis in the hips and knees, collapsed foot arches and other foot issues. We also see a lot of dislocated knees. And this is because evolution doesn't create things to be the best for their environment or for their situation. Evolution really just does its job good enough. So everything evolves and adapts to be specialized to their environment and their needs, but it isn't to be perfect in that environment. It is to be okay enough to be able to keep reproducing. Now, you should watch this last little video called Evolution of Bipedalism, and then you can ignore these due dates. I didn't update them. You should also look at the eSkeleton website and kind of play around with that and look at the difference in the pelvis and skulls and even feet and leg bones between primates that are facultative versus just not bipedal at all. Most primates are somewhat bipedal, but you should look at the facultative ones. For instance, the chimps. I can't remember if there's pictures for bonobos on the eSkeletons website, but if there are, you should look at those. Gorillas, orangutans, a lot of those great apes, compared to the other primates like the slow loris, the tarsiers, the spider monkey, all of those. And you can hopefully start to see very obviously which characteristics are indicative that something is bipedal or somewhat bipedal. Now, if you haven't signed up for a primate, please go ahead and do that. The Excel sign-up sheet as well as the further instructions for the project are up. Don't wait until the very last minute to do these. You guys don't have a final in this class, but this project is essentially your final. And unfortunately, if you turn in your paper, especially if you turn your paper in late, I can't give you an extension because I just don't have the time. It's not that I wouldn't if I could. Obviously, most of you guys know I'm pretty relaxed about that, but I actually cannot let you guys do that. So please turn your papers in on time. By the end of the semester, after like that last day of classes, I really only have 3-4 days until I have to get grades into the university through the banner system. If I don't get them in by that time, you don't get a grade. I don't think you guys want that. So make sure you get these in on time. Also, whenever you submit your videos, presentations, please remember to submit them as an MP4 file. A lot of students want to submit them as PowerPoint presentation like videos or as Teams videos. And normally that would be fine. Blackboard is just kind of a pain. It doesn't really like those all the time. A lot of times it won't give me access to those, so I can't open them. So just save you, me, everyone the trouble. Submit it as an MP4. Alternatively, if you can't figure out how to do that or you're just having issues with it, you can upload them onto YouTube. If you have a YouTube account, upload those and then share that link with me so that I can view it that way. Do double check them though, because I have had submissions in the past where the audio wasn't working or the actual video wasn't working at all. So double check, make sure. But that is all I have for you guys today. Hopefully these next few weeks aren't too bad as you guys get ready for finals. And have a good week. I will see you guys next week with a lecture video.